Okay, in this video we're going to focus on how to calculate the magnitude of a projection vector, or the length is the same thing as the magnitude. So here I'm going to project the vector 2, 3 onto negative 10, 1. So it might be good to draw a picture of what this may look like. So I've set up a coordinate system here in black, and I'll draw my vectors in blue. 2, 3 is right 2 and up 3, so I'm going to end here. Looks like this. And I'm going to project that vector onto negative 10, 1. So negative 10, negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then up 1 puts me here. So what I want to do is project this vector onto this vector's axis. And so it might be useful here to extend my axis onto which I'm projecting. So that's this guy. It would extend something like this. And then my projection vector is the vector that sits right here. So let me draw it in red actually. So that's my projection vector. Might even make it a little bigger. And I want to know its length. So what I want to do is focus in on this right triangle here and see if I can figure out this side of that right triangle. So let me redraw that right triangle over here. Let's make it thinner. So I'm going to clearly zoom in here. It looks something like this. Here is a right angle, correct? This is the right angle. And I'm interested in finding this side here. So we could call it x. And the hypotenuse, well, remember this vector was 2, 3. So that meant the horizontal is 2, the vertical is 3. So the hypotenuse is the square root of 4 plus 9, which is the square root of 13. Now what I want to do is focus in on how to find this angle, because I need an angle here to get x, or I need the other side. Well, it's not too difficult to find the angle, because if I come back over to this picture, I could find this angle here, because we know how to find the angle between two vectors. You could do it using standard trigonometry, or you could do it using dot products. Choose whatever you like. And it appears that this angle is approximately 118 degrees. So this angle here would be 62 degrees approximately. Now using right triangle trigonometry, we can say the cosine of 62 degrees equals the adjacent side x over the hypotenuse square root of 13. So x multiply both sides by the square root of 13 is approximately 1.69. Okay? So this is the length of the projection vector. So once again, we drew a picture to understand where it was. We knew the length of the vector up here, right? Because that was just the vector 2, 3. So we redrew it here using the horizontal and vertical components instead of the two perpendicular components here. We thought of it as horizontal and vertical to find the length of this vector, square root of 13. Then we calculated the angle between the two vectors using either dot product or standard right triangle trigonometry. Once we knew that, we knew the angle inside the right triangle had to be the supplement of 118, which is 62. And then we used right triangle trig to find the length of this side of the right triangle. So that is how you calculate the length or the magnitude of a projection vector.